Hey everyone! Get ready to unlock a super powerful optimization technique in JavaScript memoization. It's an incredible way to dramatically speed up your applications by avoiding redundant computations. If you've ever faced performance bottlenecks with complex or recursive calculations, memoization is your secret weapon, especially when dealing with functions that repeatedly get called with the same arguments. At its core, memoization works by creating an internal cache, typically a simple object or map, to store the results of expensive function calls. When the memoized function is invoked, it first checks if the inputs, or arguments, have been processed before by looking them up in this cache. If the arguments match a previous call, instead of re-executing the entire function, it simply retrieves and returns the pre-computed result directly from the cache. If it's a new input, the function executes, calculates the result, stores this new result in the cache associated with the current inputs, and then returns it. This means the heavy lifting is only done once for any given set of inputs. You can use this. You'll frequently find memoization indispensable when building dynamic programming solutions, such as optimizing recursive Fibonacci sequences or complex mathematical factorials. It's also incredibly useful in front-end frameworks to optimize component rendering by memoizing expensive selectors or data transformations, ensuring computations only rerun when their underlying dependencies truly change. Think about any pure function that performs intensive calculations on data that doesn't frequently change. Now let's break down the code line by line. First, we define a function named fib that calculates the Fibonacci number for n. It takes an argument n and an optional cache object, which defaults to an empty object if not provided. This cache will store computed results. Then, this line implements the core of memoization. It checks if the current n value already exists as a key in our cache object. If n is found, meaning its Fibonacci number has been previously computed, the stored result cacn is immediately returned, avoiding recalculation. Then, these are the base cases for the Fibonacci sequence. If n is 1 or 2, the function directly returns 1. This prevents infinite recursion and provides the starting values for the sequence. Then, if n is not in the cache and not a base case, the function recursively calls itself for n1 and n2, passing the cache along. The sum of these two results is then computed, assigned to cacn for future lookups, and finally returned as the result for the current n. Then, we call the fib function with an argument of 7 for the first time. Console.log then displays the calculated 7th Fibonacci number to the console. During this call, the fib function will perform all necessary computations and populate the cache. Then, we call fib with 7 again. This time, because 7 and all its intermediate Fibonacci numbers were stored in the cache during the first call, the function immediately retrieves the result from the cache instead of recomputing, making this call significantly faster. Finally, the output shows 13 twice. The first 13 is from the initial calculation, and the second 13 is retrieved instantly from the cache, demonstrating the performance benefit of memoization without any visible change in the final result. And that's memoization in a nutshell. It's a crucial technique for building high-performance JavaScript applications by intelligently caching computations. Don't forget to like this video if you found it helpful, and comment below with the next JavaScript concept you'd like me to explain.